This new section is entitled Nonlinear Differential Equations. In the last section, we talked about population, and we said that the population can be thought of as the change in the population is proportional, that means equals to k times, is proportional to their population at that time t. Now, we divide both sides by p, we get that dp dt divided by p is k, a constant. But let us suppose that it's not a constant, which kind of makes sense because when it comes to, say, population of people, for example, there's limited resources. Population cannot grow forever at a constant rate, because in the end we'd have infinite number of people, or in 1,000 years we'll have an awful lot of people, more than we can handle. So there's usually a limiting factor, a limiting value. The most number of people you can have, the most number of bacteria that you can have. So suppose that k is not a constant, but it is some function of time. Let's call it f of t. It is some function of time. With respect to this equation, we multiply both sides by p. We multiply both sides by p. The p down here vanishes, and it ends up here. So this here is our differential equation for population when it's nonlinear. Now, I said it's nonlinear, so let me just write this a little bit clearer. It's p times a function of p, actually, sorry. Now, this function, let us assume that it's linear. That is, f of p, so the variable is not x, it's p. It's going to be mx, but that's how I write x, plus b. Now, it says nonlinear. Well, of course, if I take this linear equation and I multiply it by p, I multiply by f of p, I'll get p times f of p, which is mp plus b. Distributing the p, we see that it's no longer linear. But let us assume that f of p is linear. But that equation in this box is nonlinear, because this is not linear. Okay. Now, let's talk about what happens at the limiting value. What happens at the limiting value? That means the population reached the max. It reached 20 million. And it's not going to change anymore. It increased up to 20 million and it doesn't change. Or it's just below 20 million and it's changing very little. In the limit, it won't be changing. That is, this is 0. But this is 0, what I'm writing in the limit, but it equals to the population times f of p. That is, this is a product. The product of this and that. Well, the population's not going to be 0. Population, say, is growing. It must be this that's going to be 0. Limiting factor is when that f of p, whether it's linear or not, is when f of p is 0. Limiting factor is when f of p equals 0. Now, suppose that let k equal the limiting value. So it's going to be that f of k is 0. K is the most number of people, bacteria, books, whatever, that you can have. You can't have more than that. Now, f of p, we agreed was linear, so it's np plus b. np plus b. Now, what do we know? What do we know? We have this point, f of k equals 0, and we're going to say that f of 0 is some value a. So we have 2 points. We have k0 and we have 0a. The slope will be, well, let's do the change in p, or so let me think a moment. It's going to be the change in y over the change in x. But x is p. Well, y goes from 0 to a. So it went up a. P goes from k to 0. It went down k. So the slope is negative a over k. Okay? So f of b is negative a over k, that's n, times p, plus b. Well, what's b? b is the y-intercept. We have some line. Well, we have the y-intercept right here. It's a. Why is it a? Because when p is 0, I go up a. The y-intercept is at a. So I have a. I hate having negative things first, so I'm going to write this as a minus a over k p. In fact, it's customary, I don't know why I wrote b there, sorry. It's customary to call that fraction b. So f of b is, f of p is a minus bp. So let's write down our equation up here. We have dp dt is proportional to, so it equals k times proportional to P times F of P. Which is this? Now, A is F of 0. B is A over K. And K is the limiting value. So that's what we have. And whatever it's worth, this is called a logistic equation. Now, we want to solve this differential equation. We want to solve this differential equation. And I do have one slight error. Initially, I wrote dp dt was k times p. I'm just going to write it as p times k. And then I said p is p, but k changed to a function of p. That is, this k should no longer be there. Sorry about that. So I want to solve this differential equation. So I would integrate both sides. First is separable. I'll bring this to the denominator on the other side. And I'll bring the dt up here. I can easily integrate the right side. Is t plus a constant. And I have to integrate the left-hand side. The left-hand side is, we use partial fractions. You want to write 1 over p times a minus bp as something over p. Since p is linear, I just put a constant on top, plus something over a minus bp. And in the variable p, a minus bp is linear. So I just put a constant on top. Now, if I were just working with this, if I were to get a common denominator, it would simply be p times a minus bp. If I multiplied the first fraction in the bottom and the top by a minus bp, that would be okay because I just multiplied by 1 and multiply the other fraction by 1 as p over p. Now, both denominators are the same. In fact, it's that denominator. Distributing the capital A, I get a times little a minus a times bp plus bp. And this fraction is supposed to equal to that fraction. Since the denominators are both the same, then this numerator is simply 1. So 1 is equal to, I'm going to combine like terms. Want to combine the p's and the constants. That's a constant. AA. Minus, or plus, I have bp's over there, and I'm taking away capital A, B, P. All I did was combine like terms for those two. And it equals to 1, like you said. For 1 is 1 plus 0 p's. That is, this is 1, which implies A is, capital A is 1 over little a, and this is 0. b minus ab is 0. That means they're equal to one another. If this minus that is 0, because they're equal to one another. But a, capital A, is 1 over a. You have 1 over a times b, which is b over a. So this is what capital B equals, and capital A is 1 over a. So this here, factoring out the dp at the end, is, well, let's look at this line here. 1 over p times a minus pb. We just learned what a and b are. A, which I'm erasing now, a is 1 over a. B, which I'm erasing now, is b over a. So this integral in the middle is just 1 over a over p plus b over a minus dp dp. Remember, it equals to dt. Okay. Let's solve this integral. The first thing I would do is I factor out a 1 over a here. And since it's a constant, I go all the way in front. For the first fraction, I just get 1 over b. For the second fraction, when I pull out the 1 over a, I just get b on top. And on the bottom, I have a minus dp, dt, dp, excuse me. And this equals to dt. Okay, so I have the 1 over a times the integral of 1 over p dp is just ln of p. Now the integral of b over a minus dp times dp. If I let u be a minus dp, then du is negative b dp. If I put in a minus, I bring out a minus. There's the minus I brought out. Negative b dp du. It says it. And in the bottom, a minus bp is u. It says negative the integral of ln of u. Sorry, it's negative the integral of du over u. But the integral of du over u is ln of u. So I get negative ln of u, a minus bp. So that's what I'm going to write here. Minus ln of a minus bp. I'm going to get rid of my side work. So I integrated the left side. I didn't put a constant, which is okay. When I integrate the right hand side, I get t, and I'll put a constant here. So now we multiply both sides by a. I multiply the left side by a to kill off that a in the bottom. Multiply the right side by a. So the left side, to save space, is just what's in the brackets. The right hand side is going to be a times t plus a times c. But a times c. A multiple of c is just a different c. I mean, a is the constant. It's 7. 7 times, make believe for a moment. 7 times c is just another constant. Okay, we're subtracting ln of one thing minus ln of another thing. That's ln of the division of the things. And this is equal to at plus c. If I can, please, I'm going to erase this on top. And we'll get rid of the logs. Remember, ln is just shorthand for log base e. So e to that power, e to the at plus c is equal to what I'm taking the ln of, namely that fraction, p over a minus bp. Now, we've talked about the left side many times. This is the same as e to the at times e to the c. After all, in multiplication, if the bases are the same, keep the base, add the powers, at plus c. Exactly what I have. E to the at times. Now, e to a constant is just a constant. And it's customary to write the c first. C e to the at. So this left-hand side, which I'm erasing, is just c e to the at. Now our goal is to solve for p. We want to integrate and say what p is. Well, we know one thing, this times this equals the top. A minus bp times c e to the at is equal to p. We'll distribute, and then solve for p. So here I get AC e to the at minus bp c e to the at. This is equal to p. This term has no p, minus this term does have p, equals this term has p's. I'm going to bring this to the other side. Now, I know why I'm bringing it to the other side. It has a p. They both have p's. Remember, this is p times 1. So I can factor out the p right away. I have 1 p's, and when I bring these over, I'll have plus b c e to the at, p's. P c e to the at. Okay, if I divide both sides by this amount, the right side will just be p. The left side will be ac e to the at over 1 plus bc e to the at. I'm going to divide on the left side each term. So I'm going to circle this term, and this term. And divide them each by e to the at. When I divide this term by e to the at, I just get ac. When I divide this term, remember there's a plus in front of it. When I divide it by e to the at, I just get bc. Plus, when I divide the 1 by e to the at, I get e to the negative at. E to the negative at. Okay. So this is what p of t is. With the constant. We have a constant. P is equal to AC over BC plus e to the negative at. And suppose that p of 0 is p sub 0. The initial population is p sub 0. I can solve for c now. Remember, this is p of t. This is p of t. So just using this rule here, p of 0, just plug 0 in for t. You get AC over BC plus. Now, negative a times 0 is 0. E to the 0 is 1. So I get that on one hand. On the other hand, I get p sub 0. I can solve this for c. What's in the bottom times p0 is equal to the top. p0 times bc plus 1 is ac. Distributing, I get p sub 0 bc plus p sub 0. This is ac. Bring all the c's to one side. It's this term plus this term plus that term. I'll bring those c's over. I have plus p0 left on the left side. The right side, I have a times c. When I bring this over, it becomes minus p0b. So I divide by that factor, and I now know what c is. I'm just going to write the b first. b times p0. This is what c is. So what I'm going to do is, I'm going to plug it in to the very top equation. P of t is a times c, p0 over a minus b times b sub 0. And this is divided by, we have some more room, it's divided by b times c, but this is c, plus e to the negative at. Okay, we're getting there. We'll multiply each term in the top and the bottom by a minus b p0. Multiply this term by a minus b p sub 0. That cancels out, and all that survived is a times p0. I'm going to multiply, or at least denote I'm multiplying that term by a minus b p0. This canceled out. I get p0 plus, I have to denote that I'm multiplying that term by a minus b p0. And this time, it's not canceling. Okay, so let me just get a little bit more space going. Just erase this. So now I have plus a minus b p sub 0 times e to the negative at. Sorry I ran out of room. I will write it down here. P of t is equal to that. The bottom, b times p sub 0 plus a minus b p sub 0 times e to the negative at, and on top, a times p sub 0. This here is the solution to these type of population problems where it's nonlinear and that function of p is linear. Okay, so it's brutal to come up with the formula, but now that we have the formula, we can actually solve problems. I do want to just look at one last thing. If you were to graph this, now our function in the blue in the middle, it has no constraints. It doesn't say that t has to be positive. So this is t. It turns out that the function goes like this. Goes like that. Of course, we don't really have that part, because what does it mean, population before time started? This point right here, that's going to be T0. It's getting to the right, is getting closer and closer to this line. That line is going to be A over B. Remember, we defined that B was A over K. Well, we could always interchange those two. I mean, remember, 10 over 2 is 5. If I interchange the 2 and the 5 there and the 2 there, that's also correct. So K, the most we can ever have, is A over B. This high value is A over B. So that's the formula that we use for these type of nonlinear, but also linear. The function of P is linear. So please don't think it must be linear. So this is our formula, and we're going to use this. Suppose that a student, so let's do a word problem. Suppose that a student carrying a flu virus returns to an isolated college campus of 1,000 students. Now, what does it mean, this student who is carrying the flu virus returns to an isolated campus? It means that these 1,000 students do not have the virus. Not one of them, not 7 of them, none of them. Actually, there's 999 students, and then 1 returned, and now there's 1,000. But prior to this 1 student returning, none of the 999 students had the virus. And this 1 student returns, there are now 1,000 students. Let me read it again. Suppose a student carrying a flu virus returns to an isolated campus of 1,000 students. If it is assumed that the rate at which the virus spreads, let X be the number of students who have the virus. X equals the number of students carrying the virus. If it is assumed that the rate at which the virus spreads, that's dx dt, is proportional to, equals k, is proportional not only to the number of infected students, which is x, but also to the number of students not infected. Well, if you have 1,000 students and say 3 are infected, how many are not infected? Well, do 1,000 minus 3 and you'll figure it out. If 92 are infected, how many are not infected? Do 1,000 minus 92. Don't be jumping at 8. You need to think, oh, I have to do 1,000 minus 92. Well, if X students are infected, well, let's see. I've always been writing 1,000 minus. Well, let me write it now. My goodness, where are these numbers coming from? I don't understand this. Oh, wait a minute. They're coming from there. So I'm going to write x. It's proportional to the number of students that do have the virus and the number of students that do not have the virus. Now, we need to write this like we had before. The only big difference is before we had p instead of x's. I'm going to write the x first, and then everything else will be not f of p, but f of x. It's going to be k times 1,000 minus x. This here is f of x. Okay, instead of x, or instead of p, I called it x. Now, what might confuse you is you thinking that constant is the limiting value. No. If you're going to think that, cool. Not a big deal. Use a different letter. Use M. Use M. Okay? M is the constant of proportionality. So now we have our equation. And they give us some more information. They want us to determine the number of students infected after 6 days. X is a function of time. We want to know what that is. If it is known that after 4 days, 50 students are infected. The number of students infected after 4 days is 50. And for the record, the number of students infected after 0 days, that is at the start, is 1. So our job is to find out what x of 6 is. We could solve the differential equations, but we don't have to. I mean, if I can figure out what x of 6 is, I'd go for it. But we're going to have to do that. So we like to know what p sub 0 is. We like to know what a is. And we like to know what b is. And we like to know what k is. Well, p sub 0 is the number in the population at the beginning, the number of infected students. P of 0 is 1. Now what is A? A is f of 0. Well, that's f of x, so I just plug in 0. So I get m times 1,000 minus 0. This is 1,000 times m, which is just 1,000 m. So that's what A equals. Now K, let me just write K first. What's K and what's B? K is the limiting value. What's the most number of students that can be infected with this virus? The answer is 1,000. You can't have more than 1,000 students infected. You only have 1,000 and they're isolated on the college campus. Now B is A over K. We know A is 1,000 m, and we know K is 1,000. So B is m. B is m. So let me write that down over here. P sub 0 is 1. A is 1,000 m. K is 1,000. And B is just m. Now, we know how to solve a differential equation like this. This equals that. By the way, this is linear. Okay, so that formula, this one right here, that's the one we're going to use. The only difference is P is X. P became X. So instead of X, well, okay, let's write it down. P of T is A times P0, B P0 plus A minus B P sub 0 e to the negative AT. And possibly, instead of calling it P sub 0, maybe we should have called it X sub 0 as well. P's become X's. This problem, instead of P's, we have X's. And X sub 0 is 1. So X of T is A, which is 1000m times 1. That's 1000m. Plus B, which is m, times 1. That's m. Plus A is 1000m minus B is m times 1. So it's just m. E to the negative AT. In the numerator, we have 1000m. We have m here plus 1000m minus 1m is 999m times e to the negative AT. Yeah, just recopying. X of t is 1000m over m plus 999m e to the negative AT. I'm going to divide each term by m. This one, and that one. The first one on top, that's going to give me 1000. Divide this by m, I get 1 plus 999 e to the negative AT. Just when you divide by m, that m goes bye-bye. So this here is x of t. And I guess I can say one other thing. From this line to this line, I substituted in what a was and what x0 was. Or did I? Over there I did not. I can plug in what a is. A is 1000m. E to the negative a times t. Okay. Now, there is one unknown in this equation. So I'm going to write this equation up a little bit higher. There's one unknown in there. So before I can figure out what x of 6 is, either I have to get rid of that unknown. So right now, copying on that last line, we know that x of t is 1000 over 1 plus 999 e to the negative 1000 mt. And you may say, you know what? They didn't need to give us what x of 4 was. We can just use x of 0. Well, let's see what happens. X of 0 is, well, the top is 1000. 1 plus 999. E to the negative. Well, if t is 0, negative 1000 times m times t 0 is 0. And e to the 0 is 1. this part right here is 1. And 999 times 1 is just 999. So, we get 1,000 over 1,000, which is 1. And I'll say, yeah, x of t is 1. But I already knew that. It didn't help me find out what m was. That is why they had to tell us what x of 4 was. They could have told us what f of 3 was, f of 11. So, on one hand, x of 4 is 50. And it equals to 1,000 over 1 plus 999 e to the negative 4,000m. Okay, and just for the record, x of 6, using our formula, is going to be 1,000 over 1 plus 999 e to the negative 6 times 1,000 is 6,000 times m. So I really want to know what that is. That would be good. If I can figure out what that is, then I just do 1,000 over 1 plus 999 times that number. Okay. I will interchange those two because my unknown term is down here. So I have 1 plus 999 e to the negative 4,000m is 1,000 over 50. So now how many 50s are in 1,000? If you don't, you can cross off zeros. You should know how many 5s are in 100. It's 20. If you didn't, 5 goes into 10 2 times. Don't forget that 0. So it's 20. 1 plus this is 20. Oh, this must be 19. 999 e to the negative 4,000m is 19. Divide by 999, I have this equation, which is almost that equation, but not exactly. It has the wrong power. It has the wrong power. Let me just write this out with a little bit more space. E to the negative 4,000m is equal to 19 over 999. If I divide by 4, if I raise it to something over 4, that power will become negative 1,000m. Then I multiply by 6. I'm going to get e to the negative 6,000m. I'm going to do the same to the other side, except I know 6 over 4 is really 3/2. So I get, just copying this down, I get 1,000 on top. On the bottom I get 1 plus 999 times e to the negative 6,000m. Which is that number? 19 over 999 to the 3/2. If you crank that out, you will get approximately 276 students will have the virus or will be infected with the virus after 6 days. One can say that's quite contagious. I wouldn't go against that. Okay. Now let us do another population problem. Suppose you come to learn that a model for the population P of T in a suburb of a large city is given by the following. The population of the people in this large city is given by dp dt is equal to p times 10 to the negative 1 minus 10 to the negative 7p. And they're also told the initial population is 5,000. Well, we want to be in the form of dp dt is equal to p times some linear function of p. Well, there's the dp dt, there's the equal, there's the p, then we have other stuff. Oh, the other stuffs must be equal. F for p is 10 to the negative 1 minus 10 to the negative 7p. Don't be afraid of those. They're called numbers. They're numbers. This is linear. And if you insist, I can write it like this. You have a number, call it m, times p, plus another number, call it b. That's linear. So multiple of the unknown variable plus a constant. This is certainly linear, which is good. Which is good, because we know the solutions to these. Now, what are the questions? There's two questions there. Let me try to sneak it up here. One, what is the limiting value? Okay, and number two will be, when will there be half of the limiting value? Now, what is the limiting value? Well, the limiting value is when is f for some value that gives you 0. That's the limiting value, the k. What do you take f of to get 0? Well, we know that f for p is 10 to the negative 1 minus 10 to the negative 7p. And you want to know when it equals 0. I'm going to set it equal to 0. All I know is I'm subtracting things I don't like. Fair enough. I don't like them, but I'm getting 0. Oh, those two things that I don't like must be equal to one another. Divide both sides by 10 to the negative 7, and you find out what p is. This number minus that number is 6. That is the limiting factor. 1 followed by 6 zeros, also known as a million. Okay, so now we know that k is a million. K is 1 million. And 5,000 is p sub 0. So we want to know when we'll have half of the limiting factor. Well, 2 goes into that number 5 times, and then you're going to have the 5 zeros. Why? Because 2 is going to go into each of those numbers 0 times. 2 into this large number. 2 into 10 goes 5 times. 2 into 0 0 times. 2 into 0 0 times. It's going to happen 3 more times. You're going to get 500,000, half per million. So when will that happen? When will the population be half a million? So what we want to know is P of what gives us a half a million, 500,000. Well, in order to do that, I need to know where P of T is. And if I knew, for example, P of t was t plus 1,000, then I would know t would be 499,000. That's how long it would take. 499,000 years. Okay, and you should be told that this has to be given. So you're given everything in here along with t. T is in months. So how many months will it take before we have 500,000? Well, you go back to that major equation. This one right there. This one right there. We know that P of t is equal to A times P0 divided by B times P0 plus A minus B times P0, A minus B times P0, all times e to the negative at. So we need to find out what A, B, K, and P sub 0 is. Well, we know what P sub 0 is, and we figured out what K was for part 1. Now we have to find A and B. Well, f of P is that linear function. A is f of 0. Well, this non-zero number times 0 is 0. 10 to the negative 1, which is a tenth. A tenth minus 0 is a tenth. A is 1/10. B is A over K. 1/10 is the same as 10 to the negative 1, and K is 1,000,000, so it's 10 to the 6th. This power minus that power is negative 7. That is B. It is 10 to the negative 7. Okay, wonderful. So I plug these values in. A is 1/10. P to the 0 is 5,000 over B, which is 10 to the negative 7s, times P0, which is 5,000. 5 times 10 to the 3, plus A, which is 1/10, minus B, which is 10 to the negative 7s times P0, which is 5 times 10 cubed, times e to the negative 1/10 t, or t over 10. Okay. This product is going to just be 500. That 5 I'm going to write down. 10 to the negative 10 to the negative 7 times 10 to the 3 is 10 to the negative 4, which I put on the bottom as 10 to the 4th. Plus, here, I want everything to have 10 to the 4th in the bottom. So multiply by 10 cubed, which is 1,000. Multiply top and bottom by 1,000. So I have 1,000 over 10 to the 4th minus, well, this product I just did right here. It's 5 over 10 to the 4th. 5 over 10 to the 4th times e to the negative t over 10. In the bottom, I can factor out 1 over 10 to the 4th. but it's in the bottom. In the top becomes 10 to the 4th. In the bottom I factored out the 10 over 10 to the 4th. So this, and this are gone. So I have 5 plus 1,000 minus 5 is 995. E to the negative t over 10. And I want this to equal. This is where P of t is. I want to know when it equals to 500 million. 500,000. Well, 500,000 is 500 times 10 cubed. Why do I say it that way? Because I'm going to divide both sides by 500. And then I am going to interchange those two. And when I interchange those two, things are really going to be coming together. I'm going to get 5 plus 999 e to the negative t over 10 is going to equal to 10 to the 4th over 10 cubed, which is 10. 5 plus this unknown value is equal to 10. Well, of course I know what that is. It's 5. 5 plus 5 is 10. So 999 e to the negative t over 10 is equal to 5. Divide by 999. So I have e to the negative t over 10 is 599. And now, hopefully this is easy. I take ln of this. And remember, ln of e to the anything is equal to anything. So when I take ln of this, I'm just going to get the anything. Negative t over 10. I take ln of the right side. That's what I get, ln of the right side. Now, I multiply by negative 10. I multiply by negative 10. The 10s cancel. Negative times t is t. On the right side, I have negative 10 times ln of 5 over 999. And it turns out that this is very, very close to 5.29 months. That's approximately how long it will take to have half of the limiting value. Take 5.29 months to have 500,000 people. And that's going to conclude this section on nonlinear differential equations.